Alright folks, welcome to my 5th video in my Learning C++ tutorial series. In this one I'm going to be talking about conditionals. Now, conditionals are something which allow your code to skip sections of code or to selectively execute portions of the code but not other portions. This can be quite advantageous and actually is kind of necessary in order to do more interesting things, in my opinion. And it's our first step into being able to do that. So conditionals in C++ are done with something called an if statement. That's pretty popular in most programming languages. I'm going to try to motivate our conditionals in this program by starting off with a little program to compute frequency based off of wavelength, or maybe we could compute wavelength based off of frequency. Anyway, the equation for that looks something like wavelength is equal to the speed of light over the frequency being something like cycles per second, and wavelength being generally in something like meters, but really you can put it in whatever you want based on whatever you're measuring your speed of light in. So the equation looks something like this. It's wavelength, I'm sorry about the caps there, wavelength equals the speed of light, which is generally denoted as a c, divided by the frequency. Okay? So if we had something like where we wanted to compute the wavelength based off of the frequency, what we could do is declare a variable for the frequency and then use this equation to compute the wavelength, right? So the first thing I'm going to do is declare an integer for the speed of light, and I'll call it c. So I'll use a rough approximation of the speed of light, which is more or less 300 million meters per second, right? So I'm going to use a more accurate version, 299,792,458 meters per second. But there it is, it's c, it's constant. There actually is a keyword for that in C++ called const. You might do this in another way, like pound define. I'm not going to talk about that here. Anyway, this is the speed of light. So that's fine. The next thing I'm going to do is declare a variable for the frequency. I think I want to compute this stuff using decimal places, so I'm going to go ahead and declare the frequency as a double, and I'll go ahead and write that all the way out there. And I think I'm going to get that from the user so that we can run this program several times doing more interesting things. So I ask the user to please input a decimal value for the frequency. It's not so important that it's a decimal so much as perhaps that it's a double. The user of the program might know what a double is, it might not. So I'll just leave it as a decimal value. Then I'll go ahead and read the frequency. At this point in time, I generally like to compile and execute my code. I'm pretty confident that this will work, although if you were just learning, you should compile and run often, and this is a good point to do so. Also, if you're just learning, it's probably a good idea to output, hey, I just read in this frequency and this is the value, and output it there. I'm not going to do that here in order to save a little bit of time. And instead, I'm just going to jump right into the calculation. So really all I want to do is get the wavelength, and the wavelength is equal to c divided by the frequency. This is it. So the wavelength corresponding to this frequency is, and I'll output that here. Okay, pretty simple program, just as a vision. I'll go ahead and start without debugging. You see a little window pop up here. Please input a decimal value for the frequency. Let's say my frequency is 1 megahertz, and my wavelength is 299 meters. Okay. Does that seem reasonable to you? It's a very long thing. We could try it again. Let's see. Something that you're probably used to is a number in the mid-90s using your FM radio. 98 million for the frequency, 98 million cycles per second. The wavelength is roughly 3 meters. Okay. You may have heard of something called a 2-meter radio before, and that 2-meter radio is partially based off of the frequency that it has to run, meters being the wavelength. So if you do something like 144 million, you get a number that's close to 2. So you'll see numbers in the ham radio range in the 144s in that region, and those are all corresponding to 2 meter-ish wavelengths. Okay, so this is all well and good. Where does this go bad? So let's say the user picks a decimal value of 0 for this frequency, 0 cycles per second. In order to have 0 cycles per second, this thing really just does something crazy. It says, oh, the wavelength corresponding to this frequency is 1 point-pound inf. And it's basically saying infinity. It doesn't know how to do a division by 0. If you enter a 0 for the frequency here, you have to divide by 0. If these were all integers, my program would actually crash. Since they're doubles, it does something a little more graceful than just flat-out crashing. If you'd like to see the version where it just crashes, we could probably do that. But maybe it's not needless to say, but we'd like to be able to add a conditional in here where we only run this computation if it's okay to run this computation. And it's only going to be okay to run this computation if the frequency is not 0. Okay? So I'm going to separate this assignment here from the initialization step, and I'm going to wrap this around a conditional. It's a branch. I'm only going to run this execution if my frequency is not 0. Negative frequency probably doesn't make sense, so I'll say as long as the frequency is bigger than 0, then this is code that's fine to run. I'm also going to give my wavelength kind of a default value here, and I'm going to give it a default value of -1. This -1 could be used as a marker down here. If I get a -1 out here, that would be a little weird. So I'm only going to do this computation if the frequency is greater than 0. So if I go ahead and plug a negative value here, then it says my wavelength is -1. If I go ahead and plug a 0 here, it says my wavelength is -1. Okay, both of those make sense. However, if my frequency is less than or equal to 0, I might want to do something else with the wavelength. And so I could write that in a different way. Now it turns out these conditionals are just true or false. Like, is the frequency greater than 0? That's something that you can say is true or is not true. Is the frequency equal to 0? That's another thing. You could say, is it true or is it not true? Is the frequency not equal to 0 is another thing that you can ask. So you might say, well, hey, really this only breaks if the frequency is equal to 0. So you might write something like this. If the frequency is not equal to 0, go ahead and do the computation. Right? You might do that. Maybe it's still okay to do that. And then you would need this conditional, because this conditional only applied if it was greater than 0. Of course, you are going to get a negative wavelength if you do this. It's important to note that that negative wavelength is a little weird. But if you just took the absolute value of both of those, they would probably make sense. But either way, you might write that so that your wavelength can still do a computation even if they give you a negative frequency to get something. But you might do this in different steps too. You might say, hey, if the frequency that was given to me is equal to 0, then what I really want to happen is to output some sort of error. Like, hey, you gave a 0 cycles per second frequency. Cannot compute a wavelength for that. If it has no cycles, it really has no wavelength. I guess you could consider it an infinite wavelength, but I'm not sure that that makes any sense. So that's a good error message. If it's greater than 0, then maybe you can compute it the normal way. If it's less than 0, then you could compute a wavelength using the positive value for the frequency, and maybe also give an error message here. Like, hey, using the positive value for frequency. And I'm going to go ahead and output what that is, just so that the user knows what I've done here. Let's go ahead and see what all these differences are. So now I've got 3 different conditionals. If I hit a 0, it says, hey, you gave 0 cycles per second. It still outputs this -1 down here, which we're going to fix in a minute. If I type in a positive value, then it does the normal thing. If I input a negative value, then it negates it. You can see it's got a shorthand notation here, and then still does the computation as you might expect. this is all well and good, but when there was an erroneous calculation, we still have normal output down here. And so we can distinguish between what those outputs should be by only outputting this when it makes sense. So I could move this line into each of these if I wanted to, and that would make sense. But it's probably actually better to use an if-else statement in this situation so that we always output it when we need to, but we never output when we don't. And the way I would probably do that is, if the frequency is 0, hey, I tell it that something is wrong. Otherwise, I'm going to do something different. And that something different is, I'm going to compute the actual wavelength based off of the frequency, either if it was positive or negative in some way. And then I'm going to do the output. And what's different here is the stuff that happens inside this if can never happen when stuff inside the else happens, and vice versa. So if the else branch is executed, then the if branch cannot be executed, right? Conditionals are often used for error testing. You can see I've done it in a couple of different ways. I've tested for errors. They're often used to prevent things like divide by 0. Again, you can see that I've done that here. They're often used to otherwise make choices based on user input. Like, hey, does the user wish to do this, or do they wish to do this, or maybe they want to do that. It can sometimes be used to improve accuracy of a computation. I've done that a few times. Either way, you'll find that ifs and these conditions are all very, very important in programming, and you'll see them in almost every program you write. Now, there are some things that I haven't talked about that I should at least point out. In order to test equality, you use two equals. Now remember, an assignment has a variable on the left and some value on the right, and that's a single equals. Testing equality requires two equals. Something else that you see me use in this video is doing a not equals test, and that's exclamation equals. Exclamation means not in C++. Other things that you've seen me do in the course of writing this code is greater thans, less thans. You can see those are still here. You also saw me do a greater than or equal to, or less than or equal to, I forget which one. But to do greater than or equal to, you do a greater than sign followed by an equal sign. There's no symbol to put the line underneath the greater than like there is in math in C++ code. So you just type greater than and then you type equals. In order to do less than equals, then you type a less than followed by an equals. This is pretty much the gist of how conditionals work. Now, you're probably going to be a little iffy on using these until you get out there and practice some. And so what I'll probably do with my next video is introduce a little bit of homework for you to try out. All of this is stuff that you need to try out, like practice, play with, perhaps write some code to compute the frequency based off of the wavelength, which is just the opposite equation here. I'll type it up here in case you need to see it. Frequency is just c over the wavelength. Either way, it's something you have to play around with. Learning programming isn't done by watching videos, it's done by programming. If you don't program, then you can't program. It's like watching someone shoot basketballs. This is something you have to do a lot, and you get proficiency by doing it a lot. This is really all I want to say for this video. Hopefully you dive in and practice with my short video next time, which introduces a little bit of homework that you can try out. It also kind of goes step by step with the steps that you should take as you're accomplishing your first homework. Hopefully you don't need those steps, but if you do, they're there. And then as we continue on in these videos, I'll give you kind of other homeworks where I take more and more steps out until eventually you're writing pretty huge things on your own. Okay, I think that ends video 5. This has been conditionals, using the if, using else. There is a whole bunch of stuff that you can do just with these branches. So I hope you get some practice with them and you've enjoyed. All right, bye.